And I want to celebrate the current OWASP top 10 risks. It's probably one of the most often cited document in all of application security. I think it's a step in the right direction, but I do think we desperately need some kind of awareness document of that kind for developers. And by the way, if you kind of frown at top 10 lists, you should. So let's give you a warning. This is an awareness document. This is a way to get started. This is to instantiate a company to start thinking about application security for your development shop for the first time. There are more than 10 issues. What I'm going to talk about today is not the end, it's the beginning. And if you're basing an entire application security program off a top 10 list, it's going to lead to failure. So this is a chance to have an introductory type of talk to bring initial awareness to building secure software. We'll talk about 10 major categories, do a little bit of deep diving. And again, I don't want to critique the current top 10, like Andrew's saying, it's more for the testing crowd. We need to message developers more if we want to really make a difference in the world today. A lot of the compensating controls that we see now are late in the software lifecycle. The goal of the OWASP top 10 proactive controls is to be proactive, to get developers and companies thinking about security early on in the software cycle. When you address security early, there's lots of studies we can cite. The data's bad, but the gut check is right. When you address security in design and in requirements gathering, you get that almost for free. When you're trying to fix bugs live, the legacy problem, the cost is $16,000 per individual bug is one metric that's often cited. So let's build this proactively. And this is not easy. There's a lot of moving pieces to really do good software development. The other thing is this is not an exciting talk. I'm not going to hack anything. I'm not going to break some electronic toaster online. This is minutia. And let me tell you, the work of security is not done when you hack something sensationally. That's boring in terms of really reducing risk. That's exciting from a media point of view. It doesn't do much to really help our enterprise. The work of security is done what fetch would, what's that Zen saying? I keep saying it wrong. What's fetch would carry water? The work of security is done in the deepest, dirtiest minutia of building software, of managing a firewall. There's a million little things we have to do to get this right. And we can do it if we think about it, if we list it off, if we itemize it, if we approach it in classic engineering methodologies. We can build secure software. There is hope. And if we don't, if we're not able to build secure software in our organizations, from an application security point of view, game over. Compensating controls have proven over and over again to not be the complete solution. And I'm not even really trying to sell you anything here. This is just knowledge that I put in open source. So there's no sale here. It's just knowledge that I think we all need to embrace, those of us who care about building secure software from the ground up. So step one, exciting, security architecture and design. Step one, we want to get our business, technical, and security stakeholders all in a room to agree on what the security features of software is going to be. And the more elongated and detailed this process is, the more your returns diminish. This should be to the point, lightweight, because you're getting in business leaders, technical programming leaders, and security application security leaders to make these decisions, and those are relatively senior resources. So this should be efficient. This should be very streamlined. We should get right to the point. So when we're doing security design, what should fall out of this? And let's talk about one example. Just an example of what I mean by building security in from a design point of view. Let's talk about a feature where we have to build some state into that feature. In this feature, we'll talk about account lockout. Account lockout is a security control. If a user fails to log into a certain account with the correct password for a few times, we lock the account for a couple hours or more, depending on how you build that feature. So the question is, how should a developer save the state of the current failed logins in a web application? Who votes put it in the request as a hidden variable? Who votes the session? Okay, no one's going to vote session. It's the database. The reason you don't put it in a session, because as an attacker, I can just drop the cookie every request, and you no longer attach my login attempt to a session. Now, a developer may decide to implement this with the session, and they'll test it all day, and it look like it works. The QA folks will log in, and they'll look like it works. And the hacker goes at it, they just drop the cookie, and it's meaningless. So making these decisions around state in a few other categories in the design phase, now you're starting to tell developers what security features should look like in a little more prescriptive way. This is not easy. It can be done, especially for your most security critical features. So what should fall out of design is requirements. And there's two major categories of requirements that we care about from a security point of view. Again, I'm thinking formal software engineering, more, even if you're doing DevOps and Agile, these are engineering methodologies. Let me repeat this again. DevOps and Agile, moving fast, writing fast software, these are engineering methodologies that require lots of discipline to go fast. And the faster of a software development methodology you use, the more discipline it's going to require. So there's still engineering. So I digress. Two requirements should fall out of these processes. Functional requirements. These are visual features in an application that even standard QA staff can test. We can test these features in a less expensive way. Things like the forgot password workflow and re-authentication during change password. Easy to check this. Change password, you require the original password and a multi-factor token if you're doing that. Forgot password workflow, I recommend things like forgot password cheat sheet, which I refer to when usually giving this requirement. Things like don't rely just on email for like a banking site. Use identity information up front, send them a multi-factor token in some out-of-band way, and then let them reset the password. We'll talk about that a little bit in just a moment. So these are things, if we spec them out correctly, QA staff can test. They're visual. Even though they're security features, they're just clickable features in a web application. So there's another branch of requirements that are not visible, that we can't test through traditional QA testing processes. These are invisible quality features of an application. One of them is query parameterization, which is the only tried and true way to truly stop SQL injection. This is not something a normal QA professional can test in a rigorous way. We want security testing. It's a code analysis or dynamic analysis, whatever your analysis methodology is. It requires deeper expertise or security-centric tools. Same with password storage crypto. This is not going to fall out in a standard QA test. You have to be looking at the code, looking at how the password crypto is stored, making sure they're using like the bcrypt, scrypt, other adaptive hashing or HMAC methodologies. So what I'm saying is when you do this kind of planning, you can now leverage the resources you have, usually have a small number of security resources, a lot of QA staff. You can leverage them more effectively when you're sorting requirements into different buckets. Is this exciting? Not at all. Is this critical to doing software security at scale? Damn straight it is. This is the kind of thinking for greenfield projects that are required to accomplish software security in a cost-effective way. If we wait to the end, we're screwed. In so many ways, we're screwed. And it's expensive, and then we start getting blinking boxes to fix things, and it leads you down a path of pain, I dare say. So now, developers. We want developers to write code. One of the things we traditionally have asked developers to do is build these controls themselves. And there's enough security features in the modern languages and frameworks that give us the majority of what we need as a developer to build secure software. I'm kind of a Java-centric thinker. I have the same kind of list for other languages if you're interested. When I approach Java, I use Apache Shiro. This is a flagship Apache project that gets authentication and authorization done really well. So especially access control. It was why a Shiro was built. I'll walk over the Shiro's access control methodology in just a moment. They're going away from role-based access control, focusing more on capabilities access control, which is a much more multi-tenant friendly methodology. We'll talk about that in just a moment. For crypto, I'm looking at the Google Kizar project, probably one of the only good crypto libraries in the entire Java ecosystem. They're not trying to give you low-level APIs. They're solving all the applied crypto problems. What padding do I use? Key rotation and key management and automatic generations of per-message initialization vectors, and it's compatible with Python and C++. This is a really heavy-duty crypto library. It takes me very little to set it up and call upon it when I need it. And all the difficult parts of crypto are abstracted away from the developers. This is ideal. Most other crypto libraries in all languages, they give you a easier to use interface, but you still have to make the applied crypto decisions on your own. I'll talk about this a little bit more in just a few minutes. Cross-site request forgery. Here's a home router in Brazil getting popped earlier this year. because of a cross-site request forgery attack against a home router. The point why I'm bringing this up in this section is we shouldn't be coding cross-site request forgery defense anymore. We should be leveraging our framework, struts, even Spring 2 months ago, most PHP frameworks, Ruby on Rails, they give you cross-site request forgery defense out of the box. It's a serious attack, we should use it. In the cross-site scripting defense space, there's not much out there in Java, so I recommend the OWASP Java encoder and the OWASP HTML sanitizer. Now with like 5 libraries, I have a really industrial toolkit that my developers can use to write secure code without having to reboil the ocean in these key security areas. Let's talk about authentication next, charging forward. This is we could have a top 10 list on this alone. This is a very complex topic, and it covers a lot of ground. I'm just going to dive into a few areas within here that I think are important that developers get wrong often. So password storage is one of my favorite topics. How do you store a password today? What do you think, folks? You got to do it. How do you store when you're building a web application, how do you store a password? You have to do it. Someone said hashing. Who said hashing? Hashing? So even with the salt, a salted hash is a horrific idea for password storage. Attackers, if that's all you're doing is using a hashing algorithm and a salt, and your database gets compromised, the attackers get your username, they get the ciphertext, and they get the salt. That's usually stored in the database. So with that, I can get a GPU cracking rig. This is a video game machine. I put a bunch of video cards in it, put Linux on it, some open source software. How many hash checks a second do you think I can do with a rig like that? I spend 5,000 on. I can do about 50 billion per day, 50 billion per hour, 50 billion per minute. No, try 50 billion per second for like $5,000 in resources. So your salted hash, that's a fast algorithm. I can now go to the RockU dump, Sony PlayStation dump, all the password dumps we've seen, and build a list of like 10 million of the most commonly used passwords, or I'll say 15 million of the world's most commonly used passwords, and throw them at every account 1 per second because you're using a hashing algorithm. It's fast. It's not meant for password storage in the modern era. There's also rainbow tables we can use against hashing by themselves. But even a salted hash, because of supercomputing speed in the hands of modest hackers, is a bad methodology. So I'm going to recommend this. So number 1, do not limit the size and the character types of your password. Allow any character, even control characters if you want to be fancy, and let users use a password manager and give you giant passwords. This is the first advice I want to give from the password storage cheat sheet. One caveat, anyone familiar with the Django framework, Python Django framework? It got popped just about a month and a half ago because of poor password storage. They were doing too good. They used PBKDF2. There's a key generation one-way algorithm that's adaptive, it's slow, great choice, but they didn't limit the password size. You can give, at the time, you could have given Django an unlimited size password, which caused a denial of service vector because they're using a slow algorithm. So you want to make sure that, let's max this out at like 160. Don't allow 50 megabyte text passwords. Let's say 150. That's big enough for most password managers. Number 2, use a salt. The main purpose of a salt is deduplication. A lot of the crypto books say it's to stop rainbow tables. There's better ways to do that. The real purpose of a salt is when you and I have the same password. Andrew, I'm going to guess your password. That's the same as mine.
Oh, right.
Fluffy Bunny 1. I'm sorry, I didn't mean to reveal that. So we have the same password. If we use a hashing algorithm, we'll have the same hash. If we use symmetric crypto with the same key, we'll have the same ciphertext. So how do we deduplicate our password in ciphertext if we have the same password? Use a salt. So at the time we create our accounts, we'll have a random string that we attach to the password, and then when we store random string password, it's a different random string for each user. Now, even with the same password, our ciphertext will be different in some way. So deduplication. You also get rainbow table protection, but no one uses that anymore. Next, and this is for those of you who here handles millions of logins per second. Anyone like a Google, a Facebook, or dealing with massive scale in some way? Anyone? Using a slow algorithm at scale is foolish at best. So if you're really dealing with massive scale, the common industry recommendation of PBKDF2, scrypt, bcrypt, and slow algorithms is really bad advice because these are slow algorithms. They beat up your L1, L2 cache. They take up tons of processing time, and especially bcrypt and scrypt. it takes like 10 concurrent runs of bcrypt to pin a high-performance CPU. So even though you can make it scale, it's going to be really expensive. So I recommend for the heavyweights use an HMAC and crypto isolation. Now what an HMAC is, it's an authenticated hashing algorithm. You give it the salt and password and a private key, and it spits out a hash. Now, if you can store that private key well, and even better, if you can isolate this whole process, you can really accomplish good password storage with that's just basically a hashing algorithm speed. A hash by itself is super fast. Now, the way we do this is we build a separate web service, and all that web service does is you can give it a string, and it gives you back the HMAC. You isolate that from the web application, because if you're embedding an HSM and embedding this key in the web application to do this process, when the web app gets popped, so does your private key, because it's being used by the app. That's why a separate web service, HSM, isolate the key. All it does is take the password and salt and give you back a string. It's a real heavyweight, high-speed, scalable way to store a password. But if that private key gets popped, game over. So we have to ensure that the isolation and key management's done right. If you don't have a massive scale need, then we'll talk about scrypt, PBKDF2, and bcrypt are all reasonable choices. These are adaptive key generation algorithms. You give it a string, a work factor to slow it down or loop it, and you get back a key of an arbitrary size that you pick. PBKDF2, password-based key derivation function 2, is a standard enterprise algorithm. It's a great first choice. It's available in most languages. I like to slow it down so it takes like a second in my production server to do that process. And now the attacker with the GPU rig, who used to be able to do 50 billion checks per second, he goes down to a couple checks per second. What used to take a second to check 15 million passwords against one user now takes months, years, if not longer. It buys you time to take action when password compromise happens. So no scale needed, PBKDF2, scrypt, or bcrypt. Scrypt is a pretty good choice these days. I recommend a setting of like half a gig of RAM per run, so it can't be mass parallelized attacked. Bcrypt is reasonable, PBKDF2 is reasonable. They're slow, they'll limit your scalability, but between those two choices, that's how I recommend you do password storage. And even better, who cares about your password storage? It's time to implement multi-factor authentication. By the way, show of hands, look at this password here, password1 exclamation point with a capital P. How many people in this room would this password fit through your corporate password policy to reach sensitive data? Those of you who are lying, come on. So this would fit almost everyone's password policy. And guess how common this password is? It's the most commonly used password with the common password policy of uppercase, lowercase number, not alphanumeric. This is the most common policy. And so an attacker will do a reverse brute force attack. He'll harvest usernames and throw this one password once against every user in your system and land a few. It's a reverse brute force attack. The point is, password policy in the modern era is almost, except for password size, is almost useless when it comes to attacks like this. So even better than storing your password with the right crypto is have a list of like the top 1 to 10 million passwords in use today, and do not let your users use them. And message them and say, you've picked a password that fits our policy, however, it's uncommonly common, and we're not going to let you use it, right? And so that's more effective than any other password control, in my opinion. So charge. Let's talk about multi-factor authentication. This is to stop classic brute force attack. Your password becomes a moving target. I'm not going to dwell on this too much, but interesting enough, we have a picture of World of Warcraft on the screen here. 5 years ago, World of Warcraft was a $300 million a month economy, one of the biggest video game online in history. And we had a bunch of hackers who were going after top-tier players, brute forcing their accounts and stealing their virtual equipment in the video game and then selling them on eBay for real money. So this was making hackers a lot of money hacking virtual players in a video game. But it was serious. Millions of dollars were at play, and even more importantly, Blizzard's $300 million a month gaming enterprise was being challenged. And so they implemented the Blizzard.net authenticator, the first mass consumer multi-factor system to date, about 5 years ago, and this fraud almost disappeared overnight. So against brute force attacks against accounts, I think don't do account lockout. That can be used against you. Use multi-factor. You no longer need to support account lockout. You can accomplish the same security goals. Forgot password, a lot of us use password reset links, right? How secure is email? How secure is email between your server and your customer server, the sender and the recipient? How secure is a transmission of email over the internet? It's not. And yet you're going to send a password reset link that will compromise your entire banking account? This is I think the common way we do forgot password is a bad idea. So per the forgot password cheat sheet, I'm recommending what most US banks do today. Ask identity information up front. Who are you? What's your email address? What's your account number? Maybe a security question. Send them a token out of band like you would with normal multi-factor, and then let them reset the password. This is how most every European and US bank does forgot password. If you have an app that requires heavy security, like an insurance, banking, or healthcare app, I do recommend you use a more rigorous forgot password mechanism like we've seen in the banking industry for quite some time. It's optional. It's down. It's optional. Chase uses it. Well, I'm sorry. Wells Fargo uses it. Chase doesn't. It's an optional step. There's no such thing as a great security question. There's only good ones. I know, but the multi-factor portion of this is what's most important. But I hear you. And we have a cheat sheet. Choosing and using security questions cheat sheet that at least helps you pick a good security question. To your point, there's no such thing as a great one, and I agree with you. Reauthentication. This control is almost never used other than change password, right? If you're changing your password in the system, you're going to require the user to provide the original password. But there's other critical places to require the user to log in again, especially when they're editing their email. And all of these services here, Amazon, Facebook, Twitter, and Meetup, they choose to do forgot password with a password reset link because they're consumer services. That's a reasonable choice. So if I can attack your account, steal the session in some way, and I can change your email address, what can I then do? I can trigger forget password, reset the password, and I now have full control of that account. As a side note, good e-commerce sites, when you change your email address, they wipe out all your credit card information that's been stored. That's a good control. Back to reauthentication. Whenever a user edits their email address, this is a critical place to do reauthentication in any site because it's editing really critical profile data that can be used to compromise you in some way from authentication attacks. So we have, again, Meetup, left-hand side, I'm trying to change my password. I'm trying to change my email address. They want my password. The same with Twitter on the bottom, the same with Facebook on the right, the same with Amazon on top. None of them let me edit my profile without reauthentication. I think this is a mandatory control, and I rarely see it in sites at all. So it's easy to do as well. Access control. And when we look at access control, how do most developers code access control? By the way, sir, this is all on SlideShare. So slideshare.net/Jim Manico. I'll give you the URL at the end. So kick back and you can kick back and relax. So access control. How do most of us code access control? What does our code look like when we're adding an access control rule to our system? Here's a Star Wars game, right? Just making this up. We want to check if the user is allowed to wield a lightsaber in the video game. There might be 5,000 places in the game where we're doing this, so we may hard code roles, a common pattern to do role-based access control design in your code. So if the user is a Jedi, or if the user is a Padawan, or if the user is a Sith Lord, or if the user is a Jedi-killing cyborg, that's General Grievous, by the way, and then we wield a lightsaber. And every time our policy changes, we have to write new code and push new code. 5,000 places. Hope you didn't break anything. This mechanism of access control is dead. Don't use it anymore. Role-based access control, not what ANSI says it is or analysts say it is. That's a different kind of role-based access control. But role-based access control, as we know it as developers, like we see it in PHP, like we see it in .NET, like we see it in different Java frameworks, it's all about hard-coding roles to set your policy. Don't do this anymore. This is a dead way of thinking about access control. Why? When you get audited and they ask you, what's your policy? My policy? Just go read the code. It's like a million lines. Go read that code. It's in there. If you have to change policy, you have to push code. And frankly, if you miss a role or if you forget to add this check, it's usually open by default. In a PHP file, when you forget to check for a role, that's wide open by default in most frameworks. There's got to be a better way. So another framework I mentioned earlier, Apache Shiro. This is capability-centric. It's not asking who the user is. It's not checking for a role. It's just asking, what is this user trying to do? And in this case, we're asking, is the user permitted to wield a lightsaber? I will code it once and never have to change this ever again. And underneath is permitted. I may have an access control database that does my capabilities checks or whatnot. But in the code, in the 1,000 places in code where I have to check for access control, I just check for the capability. Now this gives me good vertical access control. What about horizontal access control? What if we're trying to drive a specific car? Is anybody a Winnebago enthusiast like myself? Okay, all right. So Winnebago enthusiasts? All right, who's lying? Who's really a Winnebago enthusiast? I'm really alone here. Okay, so okay, I just want to let you know. I'm sorry? Who said what's a Winnebago? You're excused, I'm sorry. Okay, you call them motorhomes. Motorhomes? You know, a little like, a lot of movies were based on these, you know, anyways.
Breaking Bad.
So what if we, can you all lie to me for a second? Can you all lie to me? Who here's a Winnebago enthusiast? Yeah! Thank you, I appreciate that. So, we all have the role Winnebago driver. But should I be able to drive your Winnebago? Would you let me drive your Winnebago? No, you probably wouldn't. I'm pretty crazy. So, we ought to have a contextual rule. Do we give everybody a different role? Winnebago driver 7, Winnebago driver 8. That's not going to scale. So what we do is we give them the role, Winnebago driver, but do a data contextual check. So look at this code here. We're on the action drive Winnebago. I grab the Winnebago ID from the request, cast it to an integer. That's not user identity information. That's identity information about the object I'm doing access control on. So Winnebago ID, and I say, is the user permitted to drive Winnebago of that number? And bang, I never have to change that code again. And I accomplish something role-based access control doesn't do. I've done data contextual access control where roles won't help us, where it's specific to the object. And no framework I've ever seen does this, except for Apache Shiro, and they got it right. Content security policy, just briefly, I see this as access control in the browser. We set a policy, we limit where images can be loaded, where JavaScript can be executed, and if any attack gets in out of our policy, it's not executed or it's not loaded in some way. I'm not going to dwell on this. It's just another access control mechanism that's being driven on the web. I bet in about 2 or 3 years, this will be one of the key security controls we all use when building web applications. So next, query parameterization. What topic am I about? What attack type am I about to talk about? SQL injection. I know you know this already. I'm going to say it again. That can destroy your multi-billion-dollar company. APT. You hear a lot of APT talk?
Yeah.
That's a great way to scare the kids, don't you think? It works. APT, my kids, I don't even have kids, so I won't tell that story. So my neighbor's kids run when I tell that story. So APT, well, I see your APT, and I raise you single quote semicolon yet again. This attack hits a web application, a simple edit email feature, and it becomes doomed. The new email is a single quote semicolon. It ends an update statement early. Instead of updating just one user account, you just wipe the email address from the entire database. Who here really knows about SQL injection well at this point? We got it? And if you do anything out of this presentation, go get all your developers religiously to write queries with query parameterization, whether they're doing normal SQL, OQL, or whatnot. This is the most critical control. If you can't get your whole organization to code like this, game over, run away. You're not going to be able to accomplish good AppSec defense. As a quick side note, when I approach a company for the first time in a consulting kind of way, and I see that they're approaching AppSec for the first time, my secure coding recommendation is usually fix all your database queries against every piece of software in your entire organization. Why? It's the biggest risk. It's one of the easier ones to fix. It's a big win for little effort, and it tests your ability to remediate code. And if a company can't fix all SQL injection in this day and age, that's usually a symbol or a measurement that they're not going to be able to accomplish application security excellence in any way. So it's one of the easier things to fix, and it's bigger impact. The query parameterization exists in PHP, in .NET, in Java, even in good old Perl. Any Perl programmers? Anyone proud to be a Perl programmer? Anyone looking for a job as a Perl programmer? And they all go down. Liars! See? I'm proud to be Perl. We're hiring. Bum! That's the way it goes. Perl was written by an absolutely insane English major, right, who had no business writing a language. Yeah, let's talk about that later. So, quick note, how does query parameterization work under the hood? Does it do validation or escaping? No way. It's leveraging how a database builds a query plan. So when you do a parameterized query, and the hallmark of this is you have the question marks or other binding variables in the query, those are placeholders, and at the bottom where we're doing execute, we're binding our $ variables, untrusted data, into those placeholders. But what happens? I see a lot of secure coding books that says it's escaping. That's wrong. It's validating or sanitizing. It's wrong. It's leveraging the query plan of a database to provide SQL injection protection. When you send a query like this to the database, you're sending it in 2 passes. Pass number 1, the database gets the placeholder query and compiles it, and it builds what a database calls a query plan. We now have this huge plan built out in terms of how this query will access and modify data in the database. Pass 2, you throw in the untrusted data. And now the plan's already built. The query's been compiled. There's no way that untrusted data can change that traversal. SQL injection goes away. That's how it really works. And we've had this for 20 years. We've had this defense in early Perl. So if you can't get your devs to code like this, give up and run. I mean that sincerely. I'm not even kidding around. Because it's game over for your organization at that point. Yep. There's a cheat sheet, the query parameterization cheat sheet that talks about this in a fairly concise way. Next, encoding. What attack am I trying to stop here? What else? You're right, but what else? Cross-site scripting. What else can encoding help you with in other meta languages? XPath injection defense, XML attack defense, LDAP injection defense. It's an important control to stop most injection except for SQL injection. We know XSS attacks. The top attack is session theft. Suppose we're on a shared site together, or I'm a user, I edit my profile, I put this top attack in, then I email you as the administrator and I say, hey administrator, I'm one of your users, my user profile is not loading, can you take a look at it? What will most administrators do? Go look at my profile while they're an admin, and this attack launches when that happens. I grab the cookie from the current user looking at this code. This is the administrator rendering this in their browser. I grab their cookie with document.cookie, add it to a URL that I as the attacker control, and then force the victim to load an image. We don't render it, we load the image, it forces a request to go out to my evil server, and the administrator's cookie is attached to that request. This is nothing fancy, classic cross-site scripting. At the bottom we have basic site defacement with cross-site scripting. You fix this, and there's so many things I can do with cross-site scripting. With HTML5, the attack surface hasn't gotten bigger, but the actual attacks that I can do with cross-site scripting is much bigger. The defense is basically the same. The attack is basically the same. We can steal sessions, deface the site. We can undermine some cross-site request forgery defenses. We can load scripts from third-party sites. We can steal data from any page, set up keystroke loggers in JavaScript. This is something we have got to take seriously, and even in this day and age, I see some software engineering managers who don't worry about it. They call it a really low-level bug when it's, in my opinion, a very critical bug. We fixed this with output encoding and other defenses. What does your browser think you're doing when it sees this character? Your browser doesn't think this is display data. It thinks this is code. You're starting a new tag. So how can I take this character, which we enter in open text fields, and render to other users' browser? How can I render this character as if it's data and not code? You encode it, right? In the HTML context, we want to use HTML entity encoding. When the browser gets this, it's code. When the browser gets this, it's just display data. It's the less than symbol that's not going to start a new tag. And in the Java ecosystem, I don't see a lot of great encoders. There's a few good ones. I think this is a great one. This is written by Jeff Ikonowski. He's a PhD robotics compiler theory student. He went and downloaded the source code to all the browser rendering engines he could and studied how they rendered HTML before he made his choices and how to build an encoder. And this is a really rich featured encoder with lots of granular slots in HTML. No other library I've seen has this level of granularity. And especially if you're building products, or you're building your own template system, this level of granularity becomes critical. I can get away in most cases with just using these 4 encoders though. The top, I have a text area, a common widget we render in a form. And I'm going to pre-fill that value with the value from the user or whatnot. So when I take that data value on the first example and put it in a value, I got to say encode for HTML attribute. The second example, it's in a text area. Encode for HTML content. The third example is in an event handler in JavaScript. So encode for JavaScript attribute. The last example is a script block variable assignment. Encode for JavaScript block. These are fundamental controls to stop cross-site scripting. Luckily, we do see these in most languages. Java's a bit behind the times, but we do have the OWASP project, which I call production quality. Ruby on Rails has a built-in contextual encoder. The Reform project, old school OWASP, like 7-year project, it still has a good encoder for classic ASP and JavaScript and Perl. In the SAPI project, the encoder is decent if you're already leveraging it. The OWASP Java encoder is a bit faster in the Java world. The .NET anti-access library has one of the best built-in encoders of any language. So it's there, use it. So validation. We know input validation and regular expressions. That's just basic hygiene. Let me talk about some specialized validation that we run into as a developer on a regular basis. So anyone ever heard of Tiny MCE? What is Tiny MCE? What is it? Yeah, it's a rich text editor that you embed into your web page. It's the Tiny MCE library written by an anonymous developer named Spock, whatever. And this converts your text areas into WYSIWYG editors, like a word editor. Bold, highlight, numbered points, colors, all the fun stuff. But how does this widget submit and represent rich markup? As a chunk of HTML that's in a request parameter. So you have this chunk of arbitrary HTML from a third-party author, from a user. How do you verify that that doesn't have evil JavaScript in it? How do you verify it's safe HTML that you could render to any other user? How about this? You want to write me a regular expression to clean arbitrary third-party HTML5 in a perfect compliant way? No, we couldn't do that as a room. It's that tough of a problem. Regular expressions are not meant to parse complex HTML. Use an HTML sanitizer. My favorite in the Java ecosystem was one of the few donations we've gotten at OWASP by Google. Michael Samuel is the lead actual security engineer. You know, I'm a security architect, which means I talk. He's a security engineer. He actually, writes code and does the work of security engineering at Google. This is a counterpoint to Anti-SAMI. Anti-SAMI is a good library. I think this is a better design. It allows you to build programmatic policies in terms of how you're going to handle untrusted third-party HTML. And I use this for advertisement widgets as well if I want to strip out their JavaScript. So I build a policy factory, an HTML policy. I'm going to allow all the default tags plus the A tag, HTTPS links only. I'm going to allow no relative links. And then I send in the untrusted HTML. Anything that's on the default tag or this particular policy will get stripped out, and we can now safely render this to any user. This is this is written for Google level scale. It's stream-based programming. It's super fast, low memory utilization, it's an HTML sanitizer meant to be used at great scale. We have HTML sanitizers in almost every language. Pure JavaScript, the Google Kaha project, one of the better ones. In Python, the Bleach project. In the PHP world, our community has been recommending HTML Purifier, which has been owned heavy duty repeatedly in recent months. So I recommend now the HTML Laud project, a little bit better HTML Purifier for the PHP world. In .NET, you have the built-in anti-XSS function, getSafeHTML, but it's way too aggressive. It ends up stripping out things you do not want stripped out. So I recommend the third-party HTML Agility Pack, a more configurable HTML sanitizer. Ruby on Rails 4 and above has a built-in reasonable HTML sanitizer as well. Is this as exciting as hacking some electronic toaster that's online now? It's not. That toaster hack is awesome, and we'll see it at some conference next year, I'm sure. But this is how you get security done. It's not exciting. It's not glamorous. It's fetch wood, carry water. It's minutia. It's the detail, the proper engineering. That's how you really win this game, in my opinion. I'm going to skip this one just to move on. Data protection and privacy. Let's talk about HTTPS first. So what benefits does HTTPS provide you? You get 3 cryptographic benefits. This is protecting data in transit. You get confidentiality. The spy can't sniff your data. You get integrity. The spy can't modify your data without you detecting it. And you get authenticity. So when you go and visit bankofsomething.com over HTTPS, you know for sure that's the right bank. How? What system governs the authenticity piece of HTTPS? The Certificate Authority System, which is awesome, right? No, not the CA system. It's worse than that. What if I gave you, there's about 500 CAs in the world today. What if I take the private certificate of one of the 500 certificate authorities that are in your browser today, and I gave you a private certificate to one of those CAs? What could you do with it? You can sign anything that your browser will validate, and now you can man the middle in real time anyone on your network without them detecting it in any way. This is a big problem. We've even seen CAs take their private certificate and sell it to private companies for big money. We've seen that happen quite a bit. And so what do we do about this? We have a technique called certificate pinning, which can help us fix the problem with the certificate authority system. When you set up SSL on your server, you're basically creating your own public-private key pair, and you take your public cert and take it to a CA, give me your ID, they'll sign it with their private key, the CA private key, and give it back to you. Now you have a public SSL key for your server that's been signed by a real CA. In your browser, there's a list of 500 public certs to all of those CAs, and the public cert will verify if the private key from that pair was the signer. That's how your browser verifies that that's a good server. And then someone sells me a private cert to a CA. I'm out in the middle between you and the bank. You make a request to the bank. The proxy grabs the handshake, creates a fake banking certificate, signs it with the private CA certificate, and gives it to you. And I'm man-the-milling you at this point, and you have no idea. Your browser doesn't complain at all. You stop this with certificate pinning. Now what this is I'm going to grab the public cert of my SSL server and hard code it in my mobile app. I'm going to hard code it in my thick client. I'll hard code it in Chrome for Android, and soon I'll be able to hard code it in normal browsers. So that way, when someone gives me a CA valid but fraudulent certificate, my hard-coded cert will detect it's changed and reject the connection. Now, this is nothing fancy. SSH has done this for years. In SSH, it's called tofu pinning, trust on first use. You make a connection over SSH, you get back part of that key pair. If that then hard codes it in your SSH client on the spot, if someone man the middles you and changes the keys, the client will reject. So we've had this kind of protection for a while. We also have strict transport security. That's a nice to have. It forces your browser to always use HTTPS. We have certificate pruning from Zane Lackey at Etsy. He basically took the 500 CAs in his browser and pruned it down to like 6 and still supported every website that he was using. So it's part of an infrastructure defense to limit which CAs your browser will support. You'd be surprised how few you really need. And one of my other favorites in this world is certificate creation transparency. So a suggestion by Google is to force every CA to put every certificate they create in a text file, a report that they created this cert. So if all of a sudden some rogue CA creates a cert for Facebook fraudulently, we will see that as a community. Most CAs are saying no way. They don't want to reveal their customer base by revealing which certs they sign. And if you get deep into the CA system, that's trivial to do anyway. So this is the stack that I think will help make SSL as it stands today better without having to change much of the infrastructure. Because as it stands today, HTTPS, Certificate Authority System, the protocol itself is an utter joke. And we've seen a number of problems in it that are going to be really difficult to fix until we get to TLS 1.2 and AES GCM mode, glossy encounter mode. Until we can get to that in a standard way, everything else before it is broken and broken badly. I'm going to jump ahead a bit here. So what about crypto storage? We're usually told to use AES, correct? So how hard is it to encrypt data with AES and a key? Is that difficult code to write? No. Now, what does real applied cryptography look like? You want to use AES, You probably want to avoid ECB mode, that's basically plain text. You want to move to glossy encounter mode, but it's not widely available yet. So we're kind of stuck in CBC mode. This is what Google Keysar uses. Don't forget a unique initialization vector per every message. Don't forget your padding. You got key storage and key management. Confidentiality, that's all you get. So what if you want integrity? Then you got to HMAC your ciphertext, and that gives you integrity. You want to derive integrity and confidential keys from the same master key, and don't forget to generate a master key from a good random source, and good bleeping luck with that. This is why you don't write your own crypto. Some of the world's best experts at applied crypto repeatedly get it wrong because it's that difficult of an art and science. That's why I recommend Google Keysar for the Java community. Google Keysar is an open source cryptographic toolkit for Java. Things like key rotation, things like what algorithm do I pick, what mode, how do I manage my initialization vectors, how do I deal with crypto in multiple languages. So this is Python, C++, and Java. It's Google's main languages. It's probably the most heavyweight, easiest to use crypto library I've seen. Their interfaces to let them talk to HSMs, hardware security module for key storage. Anything else in the Java ecosystem, I think you're too low level. And not enough languages, in fact, no other language that I know of has a crypto library of this level of detail, in the web world, of this level of detail, sophistication, and accuracy. So in almost every other language, you're stuck doing it by yourself, and you're doomed to failure. A lot of people have told me recently, well, the era of crypto is over. And I say no. I say the era of implementing crypto correctly is just beginning. Yeah. Let's talk about intrusion. How am I in time, by the way? 5 minutes. Excellent. Let's talk about intrusion detection briefly. Just a few quick things. Let's talk about two items in a web form that are lists. You have a checkbox group, like I can provide a list of checkboxes in the same group. The user clicks a few checkboxes and you'll see the same variable name with 3 different values in your request. Or you have a multi-select list. It's like a drop-down menu, but you can make multiple selections and hit go. So there's a limited amount of checkboxes I can put in a user interface. There's a limited amount of countries I can put in a multi-select drop-down list. If all you do in code is detect when someone makes a selection outside of the choices you provided, only an attacker can do that. A normal user with the browser can't check a box for a different value. It's just not possible in the UI. But it is easy for an attacker to use an interceptor to intercept traffic and make that change. So if you detect that change from an immutable field, like a checkbox, radio button, or select list of any form, you know an attacker did that and not a normal user. This is early intel that you're being attacked, and very few of us get that. Another example that I use often is in my robots.txt file. This is a common text file for the web that will drive whether or not a search engine should hit certain pages. I put an exclusion page like /admin/secret login. I put that in robots.txt as a URL not to be crawled. And so it's never linked up in my application. But the attacker will hit robots.txt and see what I don't want to be indexed. He'll go hit those pages. So now very early on in the attack sequence, I know an attacker is hitting things that only an attacker would be looking at, or only an evil search engine would be looking at. So it's a great way to cheaply do intrusion detection. And putting this in a product is fraught with difficulty. Putting this in code is trivial. At OWASP, we have the AppSecUSA project that makes this goal even easier of embedding intrusion detection in your code. We just got massive funding to beef this out from the government as well, so we'll be putting a lot more effort into this. Big props to Michael Coates, Simon Bennett, and our project manager, Samantha, for getting us a pretty sizable grant to beef this up. I love it. Detect attacks in progress in code. I guess I'm done. I have time for just a couple quick questions. Shoot. Wait. Andrew, go ahead.
How do we get involved?
How do you get involved? Go Google the OWASP Top 10 Proactive Controls. We are open to any advice. We're looking for just people to edit. We're looking for typesetters. We're looking folks to help expand upon our 10 security areas. We're even looking folks to tell us how wrong this is and how we have to change the whole project. We are open to any advice or counsel. We're looking for community, large community to work on this. Really grateful for your time. This deck is up at SlideShare/Jim Manico. Andrew, cheers. Thank you, Andrew. Thank you, everyone else.
Very great talk, man.